I want to give you some intuition regarding this strange condition of overflow flag equals sign flag. Let's take a look, for example, at the jump greater equal instruction. Let me remind you how it works. The jump greater equal instruction checks the following condition: sign flag equals overflow flag. If the condition is met, the jump is taken. If not, the flow continues as usual. Assume that we have just executed the instruction compare ECX, EDX. So actually, we execute ECX minus EDX and then change the flags accordingly. Specifically, we change the overflow flag and the sign flag too. So there is a meaning to checking those flags. Now there is a bit of text here. Make sure that you are not overwhelmed, for example. That is because we can easily separate this text into 4 cases. All this text is just about checking all the possibilities of the overflow flag and the sign flag. In this part, we check what happens if the overflow flag is 0, and we check 2 cases, sign flag 0 and sign flag equals 1. In this case of the overflow flag equals 1, we also check 2 cases, sign flag equals 0 and sign flag equals 1. We check all the different possibilities and then make sure that actually jump greater equal corresponds to this interesting condition, overflow flag equals sign flag. So let's begin. In the overflow flag equals 0 case, we know that no overflow has occurred. That actually means, intuitively, that the result has the correct sign. It actually means that given the result has the correct sign, now we can actually believe the sign flag. We can just check the sign flag and see if the result of this subtraction is positive or negative, and take our decision accordingly. If the sign flag is 0, the result is positive. Hence, ECX is greater or equal than EDX in the sign sense. If the result of this subtraction is positive, we are going to get that ECX is greater or equal than EDX. I remind you that in this case, the overflow flag is 0 and also the sign flag is 0. So both of them equal 0 and they are equal. So this is one of the cases where the overflow flag and the sign flag are equal, just like the condition of the jump greater equal, and at the same time we have that ECX is greater or equal than EDX. So this case is compliant with this condition. Let's check the next case, where the sign flag equals 1. Given that no overflow has occurred, we know that the result is negative. Hence, we know that ECX is smaller than EDX in the sign sense. In this case, the overflow flag equals 0, however the sign flag equals 1, and so they are not equal. Let's check the next big case of overflow flag equals 1. In this case, we know that an overflow has occurred. This means that the result has the wrong sign. Let's take a moment to think about it. If the result intuitively has the wrong sign, it means that we could use the sign flag. However, we should not believe what it says. We should check the sign flag and then decide according to the other option. For example, in the first case, the sign flag is 0. Usually, that would mean that the result is positive. However, I know that an overflow has occurred. Therefore, I will think the opposite. The sign flag says that the result is positive. Therefore, I'm going to infer that the result should be negative. Hence, we get that ECX is smaller than EDX in the sign sense. In this case, we know that the overflow flag equals 1, however the sign flag equals 0, and there is inequality between the overflow flag and the sign flag. In the next case, which is the last, we assume that sign flag equals 1. Usually, it would mean that the result should be negative. However, an overflow has occurred, so we are going to take the opposite option, and we will infer that the result should be positive. Hence, ECX is greater or equal than EDX in the sign sense. In this case, the overflow flag equals the sign flag, and both of them equal 1. Let us summarize. Let's see all the cases where the overflow flag equals the sign flag. Those cases are this case, okay, and this case. In both of those cases, we have that ECX is greater or equal than EDX. We can also see that in all the other cases, we have the opposite. We have that ECX is smaller than EDX. So we can conclude that ECX is greater or equal than EDX in the sign sense if and only if the overflow flag equals the sign flag. That actually means that this condition describes pretty well what greater or equal means. We had it here, the jump greater equal instruction with this condition. So we can infer that this condition, for example, verifies well, even pretty well, that some signed number is greater or equal than another. The rest of those instructions and their condition being checked could be proved using or relying on what we found out about jump greater equal. We know that this instruction and the condition are correct. We can infer that the rest of the instructions are correct by relying on the correctness of jump greater equal. Let's look at another example. You probably remember this example of unsigned comparison. First we changed sub into compare, and then we changed jump carry into jump below. And we got a pretty simple code that describes unsigned comparison of those two numbers, EAX and ECX. If we somehow decided of some reason to change this comparison to be a signed comparison, or a comparison between two signed numbers, it would be pretty easy to change. We just have to change this instruction, jump below, to this instruction, jump less. It is pretty cool that the details of checking the flags are hidden from us. So we don't actually have to remember all the details about the overflow flag, the sign flag, and carry or zero flag. We can just change the instruction. In fact, many people don't really know how the jump below or jump less instructions work. They just use them after the compare instruction. Many people survived pretty long time in this manner. I do, however, recommend that you take some time to think about how jump below and jump less work and what is the difference between those two instructions. Some thoughts regarding readable code. Always prefer the more meaningful instructions in your program. For example, use jump below instead of jump carry if you are comparing unsigned numbers. I'm not suggesting that you should always use jump below over jump carry. For example, if you really want to check the carry flag for some other reason, we will see in the future some other instructions that affect the carry flag. In those cases, you should probably use the jump carry. However, if you are comparing unsigned numbers, I suggest that you use jump below instead of jump carry. That is because jump below better reflects the meaning of what you are trying to do. So it will be much easier for you to read it maybe in the future. It will also be much easier to read it for your friends or co-workers. Another example. Use jump greater equal instead of checking that the sign flag equals overflow flag on your own. I think this is pretty trivial. You probably agree with me on that using jump greater equal could be much easier than checking manually that the sign flag equals the overflow flag. And this is of many reasons. The first one is that you might make a mistake with the condition. You might accidentally forget the right condition for jump greater equal, and maybe you will accidentally check something else. Maybe you will check that the sign flag is not equal to the overflow flag. Another reason is efficiency. The jump greater equal checks this condition pretty fast. If you are going to check it yourself, it will probably take you more instruction, and therefore it will be a bit slower. If you do use assembly to program, you probably do care about speed to some extent. The last reason is readability. Many people don't know what this condition means. It has no meaning for them because they didn't take the time to think about it. However, most of the assembly programmers understand what jump greater equal means. Some other notes. The processor doesn't care. You could use any of those, and as long as it means the right thing, for example, for you, the processor will just do it and the program is going to work. The processor doesn't really care about your choices. The program is just going to run. However, doing the right choices of instructions, even instructions that have equivalent behavior, should make life easier for you and for your co-workers, because it will make your code much easier to read and maintain, and also to understand. Summary. We learned that the compare instruction is just like the sub instruction. However, it doesn't change the compared values. It does affect the flags. However, it doesn't change the compared values. Unsigned comparison should be done using those instructions. Jump above equal, jump below, and jump below equal. Signed comparison is done using those instructions. Jump greater equal, jump less, and jump less equal. Try to prefer meaningful JCC instructions in your code over instructions which are more basic, like JC, JZ, JS, and JO, mostly because of readability reasons. See you next time.